Welcome to a video on consequences of the factor theorem. So in the last video we looked at factorising polynomials, and one of the theorems we looked at was the factor theorem, where if x minus alpha is a factor of p of x, if and only if p of a equals to 0. So that's p of alpha, equals to 0. So if I sub alpha in and it equals to 0, we get a factor. From there, you can use trial and error to find an integer 0, the integers to try the factors of the constant term of the polynomial, and then you can use long division or process of elimination to find the other factors. So that's what we learnt in the previous video. So when we look at identical polynomials, for them to be equal, the coefficients of the corresponding terms must also be equal. So that means the coefficients of the x squareds, the coefficient must be equal, the coefficients of the x's must be equal, and the constants must also be equal. So here's an example. We're going to find the values of a, b, and c. So the first thing we do is we expand the brackets. So when you expand x minus 3 squared, you get x squared minus 6x plus 9, and then you multiply each term by a. Then you just expand b outside of x minus 3 normally. And then in the third line, you'll see that we've collected all of the terms, the like terms together, based on their x's. So the x squared only had an a, the x was minus 6a plus b, and the constant terms are 9a minus 3b plus c plus 2. So, equating the coefficients, so the coefficients of x squared, a equals 3. Coefficients of x, so on the left-hand side you've got 2, and on the right-hand side you've got minus 6a plus b, but we know that a is 3, so when you work that out you get b is 20. So currently we have a is 3 and b is 20. And then you do the constant terms. So on the left-hand side, you've got 5. On the right-hand side, you've got 9a minus 3b plus c plus 2. Sub a is 3 and b is 20, and you get c is 36. So geometrical implications. So obviously, if two polynomials are equivalent, then the subtraction of the two and solving holds further properties. So if p of x equals q of x, then if I minus q of x across, I get p of x minus q of x equals to 0. Now, if you're able to factorise that, then factorising it, getting a factor of x minus alpha, means the two graphs intersect at x equals alpha and they meet at an angle. If you get a square bracket, so if you get an x minus beta all squared, it means the two graphs are tangents at x equals beta. Note the two polynomials cannot intersect in more points than the highest degree, and a line can intersect the graph of a polynomial in no more than n points. So here's an example. So we've got p of x, q of x, and we're going to factorise p of x minus q of x. So obviously we're going to subtract them first, and then we're going to describe the intersection between the curves. So subtracting them to get f of x, you get x cubed plus 4x squared plus 5x plus 2. Using the factor theorem and then long division, we get f of x equals x plus 1 squared and x plus 2. Describing the intersections. So since we've got an x plus 1 all squared, that means that x equals minus 1, the curves are tangents, and our other bracket is x plus 2. So at x equals minus 2, the curves intersect at an angle. Finally, multiplicity of zeros. Once a zero of a polynomial is found, if it's also a zero f dash of x, then it's a double zero. really handy to be able to find quick ways of finding off factorising. And then if it's a 0 of f double dash of x as well, then it's a triple 0, and so on. So we're going to have a go at factorising this polynomial. So if we factorise, so we just sub in 1 and 2. When you sub in 1 and 2, that gives us zeros at x equals 1 and x equals 2. Differentiate, sub in 1 and 2 again. So when you sub in 1, you get 0. So that now means we've got a 0 of multiplicity at least 2. And since p dash of 2 doesn't equal 0, that means we've got a single bracket for 2. It's just a x minus 2 bracket. So p double dash of x is equal to 12x squared minus 30x plus 18. When you sub it in again, you get it equal to 0 again. That means x equals 1 is a 0 of multiplicity 3. And since it's a degree of polynomial 4 and the other one was an x equals 2 as a single 0, we can't go any further anyway. So it'd be pointless. So that means that px is equal to x minus 1 cubed, x minus 2. Thank you.